There's class on Thursday, maybe. I'm really tired. I graded your papers till 6 o'clock in the morning today. There's class on Thursday, maybe. I'm really tired. I'm not sure how functional I'll be. So let's talk about the test for a little bit. It was interesting. I think I sent you an announcement. Yes. Am I sharing screen? I'm not sharing screen. Okay. Hold on. So I am sharing screen how? No. Here we go. So I finished all the grading that I have for you guys. I'm very sorry that it took me so long. I've been grading my other two classes and I completely omitted grading most of your discussions. So I finished them all. I'm not sorry that I took so long. I'm sorry that I was probably more generous when I went through. I wasn't as careful grading them as I should have been because those questions did make it to the test. And if you weren't doing units on the discussions, you might not have done units on the test when it said, say, your answers include units and whatever. So those discussions are really meant to help you on the test. Now, you have a couple of things that will help rectify this before the final. First of all, you know it's coming on the final. Secondly, you have a discussion, you have a project due between now and then. That's basically you doing both the writing, you're doing everything. You're doing the writing, you're doing the speaking, and that worksheet, you're going to present it, but we'll talk more about it later, and you're going to record it on a video. Okay, and that will be your own independent research project. And any points that you lost in discussions, I can help to, well, I'll let you know how that works later on. But if you didn't do well on this midterm, but you thought you should have, I just wanted people to understand what sorts of questions that I ask. I wanted you to get a feel for what it's not how you did on this midterm, it's how you're going to do on the final. Are you making progress? Are you figuring this stuff out? Does it make sense to you? The first time the test was really weird. You maybe didn't expect a spoken test, and a lot of people make mistakes on that test by not saying things or not saying them the right way. This test was even more so, but it wasn't that much more so. And if you can figure this out, the final is going to be pretty much this midterm, or a lot of this midterm. Honestly, the final is 2/3 this again, and 1/3 integration. Okay, so the stuff we're doing now will make up about 7 or 8 questions on the final, and those 7 or 8 questions on the final will be there'll be 7 or 8 questions on the final. So we have about 6 weeks to get to the final. So we only have to pick up a question or two each week. So we actually are going to slow down quite a bit. We moved at a pretty good pace. I wish there was more integration on the midterm because we're doing a lot of integration. But yes. Anyway, do you guys have any questions on what I sent? I've already forgotten what the grades were. thought they were good. I think in your class, somebody got a 90 something. Hold on, let me pause to share and I'll tell you. In your class, now I haven't, this is without the curve. Okay. The highest grade was a 95. Okay. Then there there was one in the 80s. Those 80s and 90s after the curve will both be A's. You're there were 1, 2 in the 70s. Those are B's. There were 1, 2, 3, 4. 4 in the 60s. Those will be C's. Actually, there's one that was 57. That will also be a C. And then there was a 55. Oh, look at that. Okay. There's a 55. That's also a C. So the people who didn't, there were some people who didn't pass this. Why are they not here? Because they dropped the class. That's too bad. Okay. Anyway, so if you're talking to me, if you're listening to me, you probably passed. And most of all, this is a lot like the final. So if you can pass this, you can pass the final. Please read the comments, though, that I put in the discussions. I put on the discussion, I put attached to your test because there were some things that are not good. And I don't want to see them on the final. One thing I don't want to see on the final is I don't want you taking the test from bed. Do you know who? There's so many people that took the test from the bed, and you can't scan the room if you're taking it in bed. And I wouldn't normally care, except people are pulling stuff out from underneath pillows and blankets and stuff, and you can't have those things. You can't have paper. If you're writing on paper, I'd have to give you instructions on what paper and how to scan it. It's not enough to just say, you know, this is blank paper. You can't have it around you at all. It's not blank. Even when people scanned paper, I had problems with it because they didn't show all the paper. So they just pick up a piece of paper and they pick up the same piece of paper and there was a whole bunch of notes underneath. And that's really what I'm trying to avoid. Okay, I don't want you to have the notes. If you need something in formulas, whatever, you can ask me, but formula sheets are with some of those things belong. But yes, so don't take the test in bed, and don't take the test. It's when you scan the room, too many people were not scanning the whole room. And that's a problem because I really need to see every part of the room. Okay. Can y'all hear me still?
Yes, we can.
Okay, do you guys have any questions? So about this test or any other aspect of this test? No. Okay. How I stopped sharing. All right. I just wanted to tell you again, because this format is not 100% new to me, but some of the stuff is. And I watched, there were some really beautiful, I saw some really nice tests. And I think if you see a thank you at the bottom of your test, it's because I was really thrilled. There were some people that really answered the questions the way I wanted them answered. Okay. I just enjoyed, if you answer the question verbally, like some people were typing the answers first, and you can't do that. Just answer the question. if you answer the question and it's correct, I just move on. I say, yep, good points. I move on. Even if you say, oh, no, I mean something else, I've already moved on. But if you get it wrong and you say, oh, I mean something else, and you start correcting it, I'll listen. But what happens is the longer you take, the more likely it is I'm taking off points. So if there's some point where I stop listening because you've already lost, you're never going to get back the points that you've lost because you're taking too long. Okay, I don't enforce that, but pretty much it seems to me that 30 seconds is about all you get to answer these questions. If I click the 10-second button 3 times and you haven't said anything, I'm taking off points. So it's not necessarily worth it trying to correct your answer if you're only lost a little bit. If you have a little bit wrong, you're not gonna get those points back. But I will say that if you can just keep talking, you can talk and you can make notes, but I don't grade the notes. So they're not, even if the notes are right, if you derived at them after I've already graded it, then it doesn't matter. Okay. Oh, look, somebody's here. Hold on. Well, hold on a second. Hold on. Hold on. Okay, so yeah, so if you need a break, if you need to rest, those questions where you speak, I'm listening at the beginning of those questions. So the end, you can pause, you can take a breath or whatever. I did see, not from any of you guys, but I saw this one student, she was drinking water, lots and lots of water. Every time I looked up, she was drinking water. And then she got up a couple times to pee. You can't do that. That's not, if Honor Lock doesn't flag you for that. And I'm watching a lot of these tests. It took me a long time because I watched a lot. And again, that's because this is relatively new. The good news is I'm watching the test and it's helping. I look at all the stuff that you do. And in the end, I curve the test. So if I take this is why I curve the test. So if I take a lot of points off, because this is relatively new to me, I'll give them back when I see what all the grades are. I mean, I don't have to give them back because there seem to be people getting grades in the 90s, and that's good. But yes, but I don't want you guys to be punished. If you're working, it should show on these tests. And that's why I say it's very doable. Passing this course is very doable. But you have to work at it because there were a lot of questions that were, just they're the sort of questions you'll know if you come to class or you watch the videos or you ask questions, that you'll get those points. But some of the questions, some of the people, if you mispronounce something like hyperbolic, or like I understand mispronouncing. Some people said integral, they said it wrong, but we just started doing integral, so I can understand integral instead of integral. But somebody said cosh in my other class. I think somebody said cosh cosine h or something, or yeah, I think they said cosine h, and that's not really that means they didn't watch the videos, and I take off points for mispronouncing things that should be said. I mean, what I'm trying to do is get you to I'm trying to get you to be able to answer the simplest questions so that you can answer these questions so you can use them. If you don't know what this course is, you can't access it. If you want to find a rate, you should be thinking calculus. If you want an average rate or an institution, you should be thinking calculus. If you're thinking about how fast something is changing, you should be thinking about calculus. Okay. You should be able to answer it when your kids ask you, Daddy, what is calculus? You should be able to say, oh, calculus is the study of change. It's math is a language, and calculus is the study of change. And, this is how we compare how fast, the slides are at the playground, which one's faster, and by how steep the slope is, and you give it a number, you have a number for it. You can compare them. Okay. All right. Any questions at all about this test? But the important part is the final exam. That's the next grade. You only have there's only two more things I'm going to grade for you: the final exam and your independent research project. Let's talk about your independent research project for a second. Let's start with Slade. Hey, Slade, what are you going to do your independent research project on? Do you know?
I do not.
No. Okay. That's not good enough. Do you have any hobbies or interests?
Yeah, I like baseball.
There's a lot of numbers in baseball.
Yeah.
Why don't you do something with baseball? Would that be okay?
Yeah, that'd be good.
Cool. Are you a Mets or a Yankee? Not Mets, LA or New York fan?
I'm a Mets fan.
So you don't care which one wins the World Series?
I'd prefer the Dodgers because I hate the Yankees, but
No.
yeah.
Okay. There you go. Well, I hope that comes across in the topic that you choose. So, okay. How about Jonathan? Jonathan, what are you doing yours on?
I'm thinking of doing it on the average price of cars over the last 50 years.
I don't know. I like to read books and play video games.
Uh-oh. Okay.
You called on me, right?
I did, but I was thinking of Eric. That's very interesting. So I don't know. I'm very tired. I was upgrading papers last night, really late.
Understandable.
I was trying to make your deadline so people would know where they stood in the course. So I literally was up until I finished grading at 5. And I went to sleep around 6. And I woke up at 10.
Oh, I don't know how you're doing it.
That's a half a day. Yeah. Anyway, so Eric, you like books. I'll get back to you, Jonathan, in a second. Eric, you like books?
And video games.
Because which one are you going to do? So what's interesting about books and video games is that books were sort of replaced by TV and movies, and video games are probably going to replace TV and movies, I think. If you watch a movie, that's nice. But being immersed in something like a video game, when they get to be immersive and interactive, and you can go to France. I mean, it's not called a video game. What are they called when you can go somewhere virtually?
Let me guess, is it a virtual reality?
Yes. Holy crap. I would love to go to France with my virtual glasses on and just walk around and interact with people. That would be so much more interesting than watching a movie. Or what the hell? Why not watch a movie that's a virtual reality movie? The characters interact with you like a video game. I'm sure they already have that, do they not? They do. All right, so Eric, there's lots of opportunities there. Which one are you going to do? Books? Are you old school or are you video games new school? You're going to have to pick one or the other.
Both.
Both?
The middle.
If you're going to do both, you can only get one piece of data from books and one piece of data so you have to link them. So you might say, how many books were sold this year and how many video games were sold this year and compare them from year to year. Like maybe during COVID, there were more video games, but maybe during the 2008 recession, there were more books. I don't know. But you can compare them, but you only can get an X coordinate and a Y coordinate, and you're trying to establish some causal effect like that. Books, when the books do well, the computer games do not do well, and vice versa. But if you don't have a correlation, you're just going to have a scatter of plot points and not going to be able to talk about change. So pick one, usually pick one or the other if that has a problem. So just stick with one data point. But okay, let me go over to Jonathan. Jonathan, you really like cars?
Mm-hmm.
How many do you have?
Well, I mean, I've had 3 different cars this year.
You've had 3 cars this year?
Yeah, I'm indecisive.
I have 3 cars right now. And they're the same 3 cars I've had since 1999.
Oh, that's pretty good. They've been lasting.
No, just one of them's from 1999. The other, my newest one's a 2018. No, and it's not because I'm a connoisseur of cars. It's because I'm a hoarder. No, I think I'm attached to them. I can't get rid of them.
Whatever works.
No, but anyway, cars are good. I believe you. If you have 3 cars this year, cars are your thing. Cars are your jam. Used to be lots of people were in cars. There still are. As long as it's not a Tesla. Hate them. And that refrigerator.
It's not a Tesla.
Hate those refrigerator vehicles. They're hideous. They look like tanks. I'm not sure that's not and that's not intentional, but anyway. Thank you, Jonathan. Luke, what's your interest? What are you going to do yours on?
I was thinking something like music related, so maybe like Spotify streams or something
Like music?
over the years. Yeah.
What's your favorite music?
My favorite music? What you mean?
Yeah, what do you like? What type of music?
I like a bunch of stuff. I don't know, like R&B, hip hop, alternative stuff is cool.
Okay, I believe you, but none of those are my favorite.
What's your favorite?
What's my favorite? I don't know.
Uh,
I'm not. I like some of all of them. I like music from the 70s, though. Ever since somebody told me this, I was told that music in the 70s is the best music. And I don't mean disco music. I mean the music they made in the 70s was a much higher quality than it is now. Not technically, but no, technically. I mean technically. I don't mean like they had better technology. I mean that there was so much money in music in the 70s. All these, like, you know, how many mega millionaires are there in music right now? I mean, there's a few, but not like there were in the 70s. Like there was every Tom, Dick, and Harry that played a band was a millionaire because there was a lot of money in music then, and there isn't now. It's in movies. There's a lot of wealthy movie stars, which was not true in the 70s. In the 70s, the movies were kind of crappy, but the music was good. And so and as I said, the video games will probably be replacing movies. So anyway, I like 70s. I like well-crafted music, but I kind of like songs from the 70s in general. I do like R&B from the 70s. Hip hop, I'd like to dance to sometimes, but what was the other thing you said? Hip hop.
I don't remember. 70s stuff is cool too. I like soul music. That stuff's great.
There you go. I don't care for rap music though, which I don't know if that's even a style anymore. It's like eaten up into various things. It's more of a technique than its own genre or something. Anyway, let me go on. Good. That music, anything about music is fine as long as you can measure it. Sales, production, quality. Quality is hard to measure. How much you like is hard to measure. But okay, Carlos, are you in this class? Carlos, you online? in this class?
Yes, sir. I'm here.
Okay, Carlos, what are you gonna do yours on?
I like sports and electronic devices, so I don't know.
What's the other thing? I'm sorry, I couldn't hear you. Sports and
Electronic devices?
electronic devices. What's your major?
Electronics.
Oh. It's up to you. I only have, I have 3 more people to do, but I'm gonna make a comment about why I'm doing this, why I'm wasting so much time talking about this. It's not really a waste of time. If you can't, when you go out in the real world, I want you to think about calculus as something you can use. Okay, so I like the sports thing because it's so different. You might not think that you could use calculus in sports. But electronic devices, you can too. You can do the storage capacity, electronic storage capacity. You can do how fast they are. You could study. It has to be something numerical, like the number of innovations, not the quality of the innovation, unless you can measure it numerically. Okay.
Okay.
Sports is easy. Alicia.
Yeah. Yes.
Yeah,
Can you hear me?
I did. Next time when you take the test, you're going to clean your desk off.
Yeah, my bad. You didn't have to call me out like this.
No, clean. It is sad that I remember this, but you really pissed off Honor Lock.
Yes,
that.
I did. Most of the notes were chemistry notes. I'm really sorry. I just didn't have the time to clean up my desk because I had work previously, so I'm really sorry about that.
For the final, you will have a nice clean desk.
I will. I'm really sorry.
Even if you have to take everything and throw it in a black garbage bag, just make sure it's not visible to Honor Lock. They make me watch it. Then I'm like, what? Then I'd see how messy your house is or your room is, whatever it is. Which
Okay.
I don't care.
Got it.
Okay, so now what are your hobbies and interests?
Well, for the project, I was thinking about doing something in relation to books as well. Probably either sales or the type, like what genre is dominating the market. I'm still thinking about it, but I want to do something related to reading.
Cool. Well, if you're going to do a genre dominating the market, find a genre that's dominating the market and then track it. Don't try to compare genres because they're so uncomparable. You can't compare romance and science fiction in any way. Nobody's going to say, well, maybe there is ways. I don't know. The more romance there are, the less science fiction there is. I don't do. But you could compare romance. I was talking to a young guy the other day, and he confided in me that he likes Hallmark movies, calls them chick flicks. And I was like, don't say that out loud. No, no. Just you never know whether a genre is more popular with a certain age group or a certain gender, but you can't. You have to track something that's measurable. You can't compare different genres or different groups of people that like them easily, unless it's something that's numerical like age. Okay,
Got it.
good. You can do it. Acacia.
Yeah.
What's your-
So I'm doing something movie related, so, like watching the TV, like how long they put like the time for the movie and how long the movies actually is without the ads. So I'm gonna compare the movie, like how long the movie is and how much time they put into ads or commercials.
Yes, you could do that. I'm not sure. So the length of the movie and the amount of commercial time. I don't know. I feel like it's going to be too linear. You want to stay away from linear topics. In other words, if the movie is 1 hour long, it has 10 commercials. If it's 2 hours long, it has 20 commercials. If it has 3 hours long, it has 30 commercials. That you want to stay away from. But but if you can track, it's a really tough one. So this thing about commercials is, you ever watch a TV show and find out that they squeeze all the commercials in just before the end? If you could track that, I would be very interested to know the amount of commercials in a movie. As it throughout like the first 10 minutes of a movie, the second 10 minutes of a movie, that you would literally just sit there and watch a movie and count how many commercials there are at each 10-minute interval. And I'm betting you that the last 10 minutes will be mostly commercials. Make it bigger, like 20 minutes, and you'll see that they squeeze in all the commercials at the end. You know, you think
Okay.
that, yeah, but I believe you're into movies. What's your favorite movie?
Anything that Marvel creates.
Might hate Marvel movies.
Why?
Okay, so one year, like 15 years ago, a bunch of students told me to watch a video, and they said, "You'll love this video, it's hilarious." And I sat there and I watched it with them, and they all laughed hysterically, and it was all this super over-edited video. It was just terrible. And I realized when you're young, those over-edited videos make you excited because they play on your fight and flight thing. So they get exciting. Your brain actually responds to that. But when you get older, it's like taking medication. It's just another annoying thing in your bloodstream that you, I know, it's so sad. But they were all thrilled. They were laughing hysterically. I was like, it's so nice to be young and find this funny. I didn't find it funny. I found it annoying. But again, Marvel is like that. There's too much the action. I skip over. Whenever there's a fight scene on Marvel, I just skip over it. And I try to
So
figure out.
you don't like action then?
Yeah, I don't, it's just too much. It's over edited. I thought you were going to talk about over editing in movies. Editing is back in the olden days, they didn't edit as much. And now they edit a lot, and I find it annoying. It's just too much bouncing around. Like those Marvel, there's a fight, it overstimulates me. I can't go to bed after watching a Marvel movie. I don't know. Do you know what I'm saying?
Yeah.
Do you go to bed right after a Marvel movie? I bet you can't.
Of course. Sleep like a baby.
Well, I can't do it. And I can go for a jog right before I go to bed, and I have no problem. But when I watch a Marvel movie, I have to do something else. Grade papers. Anyway, keeps me up. But all right, so those are good topics. Aiden, think you're going to get off the hook? What's your hobbies or interests?
Singing something music related. Trying to come up with something that regarding like musical notes or pitch, something like that.
The thing about music is I'm very fascinated by music. My cousin is I have a cousin who's a department chair of a jazz department in Boston, some conservatory, I don't know, some music conservatory. Anyway, I was asking him about sad notes. I said, why are these notes inherently sad? There are notes that are sad and there are notes that are happy. And I don't understand that at all. I'm like, but the chemist in me understands that there's frequencies that vibrate molecules and they have to be at certain frequency. Your microwave your microwave that you use to cook with, it literally takes water molecules and it rotates them. A certain frequency of microwave hits the molecule and makes it rotate. And those frequencies are no different than musical notes. So maybe musical notes rotate your sad molecules, and that makes you sad.
Yeah.
And then if it, maybe it slows them down, maybe it rotates them instead of vibrating them or something. I'm happy when it's vibrate them. I don't know, but it's very interesting, but I think it might be complicated, but I'm interested
Yeah,
to see
I'm
what
trying
you.
to think. Like, make it not so hard or anything, I just think it's simple.
The other problem I have is the frequencies are, they're blocks apart. They have to be a certain way. They can't be continuous. There's like this stuff, like there's like a note, like an A node. What is, doe, a deer, female, I don't remember what they are, but they have to be, there's not much between them. There's like this note, and then there's the next note, but there's nothing in between. Well, there
There's like
is,
a period or
but it has to be a certain wavelength. So it can't, there's probably an infinite number of wavelengths, but the way we can't distinguish them. So we only distinguish certain wavelengths. All right, let's move on then. Okay. Mod 8. Let's talk about Mod 8. Okay, so let me talk about the summation stuff. Write in summation notation the first 215 odd numbers. Well, let's just start off by adding the first 5 odd numbers. What are the first 5 odd numbers? Let's just start off by adding the first 5 numbers. 1 plus 2 plus 3 plus 4 plus 5. That's 15. Okay, we'll work our way up to that. So we want to have a notation, a summation notation that says start with the number 1 and end with the number 5. And then we'll say n is what we're going to do. So look, that just gave us the answer. What does that mean? When I use this notation, what does it mean? It means literally copy this, copy, paste, and then replace it with the number 1, because that's the first number we have here. And then it says, then do that again, plus, go up here, take the n, copy it, paste it, and then replace it with the number 2. And then paste again and replace with number 3. And then paste again, and so on, until we get plus 4 plus 5. Okay? So now, how do we get odd numbers? So that's the notation. How do we get an odd number? What are the first 5 odd numbers? 1, 3, 5, 7, and 9. Now, the important thing to note is how far apart are these odd numbers? How far apart are they? They're 2 apart, right? So our notation should be something like 2. Like if we doubled them, like if we didn't do that, what does that give us? When we just say 2n, what does that mean? It means take the 2n, copy it, paste it down here, replace the n with the number 1. Then copy it and paste it again, and replace that again with the number 2 times 2. And then again, plus again, replace the n with the number 3. Okay, are you getting the pattern here? I just again replace this with the number 4. And when do I stop? When do I stop? Do I stop now? Yes, I stop when I get to the last one. Okay, you see how if I add up 2n, that's what I'm doing to all of that. Now, what are those numbers? What's 2 times 1? 2 plus 4 plus 6 plus 8 plus 10. Okay? That's what I'm adding up. 2, 4, 6, 8, 10. Those are the first 5 even numbers. What would the first 5 odd numbers be? There they are. Isn't that just 2 minus 1? Isn't that 1. And this is 4 minus 1, 3. And this is 6 minus 1, 5. And this is 7 minus 8 minus 1, 7. This is 10 minus 1, 9. So how do I write that in my sigma notation thing? If I want that. So if I wanted to do 2 times, so remember I was pasting, I just want there to be minus 1 there. So I really just want them to, I want this to be minus 1. And is that what the first 520, is that what they add up to? Yes. See, that's what it adds up to, 25. Okay. So how do I get 215 odd numbers? I just changed this 5 to 215. There's the answer. How cool is that? The wonders of technology. How about the first 215,000? These are some of the first 215,000 numbers, odd numbers. Okay, Desmos, super powerful. Don't tell me the calculator's better, it is not. Okay, so write the summation notation. This is the summation notation, the first 15 odd numbers. And you would say this, the sum is n equals 1 to 215 of the quantity to n minus 1 n quantity. Okay, please note, it's not this. Those parentheses have to be there. If I do this, I get a different answer. Why do I get a different answer? Because it's basically adding up all these even numbers and then just subtracting 1 from it. Okay, from the grand total. So the parentheses have to be there in order to get this right. Okay. All right. Let me show you something else, a pattern here. 1 plus 3 plus 5 plus 7. Let me just do 1 plus 3 plus, let me do these for a second. 1 plus 3 plus 5. Look at this. Okay. Let me do this bottom one first, and then I'm going to show you how to do the top one. Do you notice that the first one and the last one are both numbers we have? On the summation thing, the 1 is the bottom and the 7's on the top. Okay, so I'm just going to call the last one is 1. Hold on, so last is 1. And the first is 1. The last is 7, and the first is 1. Okay, so what does that mean? What does that add up to when we add them together? What's 7 plus 1? Right? Isn't 1 plus 7, 8? What if we add up these middle two? What do they add up to? 8. Okay. And they stop because we reached half of the numbers. We're really only adding up these 4 numbers. First one is 1, and the last one is 8. And then we're going to, if we want to know what that total is, we have packets of 8. We have literally 4. We have 2 packets of 8, which is half of the number that we have total. So if we went from, well, last isn't 7. I'm sorry. Screwing this up. The last is actually 4. So there's 4 terms. 1, 2, 3, 4. So the first term, the first term is 1. The last term is 4. When we do this summation sign, that's what it will look like. Okay, so this would be the sum. Sum from 1 to 4 of 2n minus 1. Okay, so the first one is 1, and the last one is 4. They come right up here, 1 to 4. And then we notice that each one of those packets is worth 8. There's a packet here and a packet there. And it's always going to be that way. whenever you have one of these things that are in order, if you take the first one and your last one and you add them together, it's going to be the same as the next two in. Because it's changing by the same amount. So it's going to be, the packet sizes will be 8, will be the first plus the last. So it'll be, this is going to be equal to 1 plus 4. The first plus the last. And then how many of them are we going to add up? Well, you're going to take the number 4 and you're going to divide it by 2. Okay. Oops. And that's not what it's from. That's what happens if you do this. You take the first one and the last one's 5, and you put a 5 there, that's what you'll get. Because each packet here is worth 6. And how many do you get? You get 2.5. The 3 is half a packet because it's in the middle. So that's the formula. This is a formula for taking a summation. If you have a summation of numbers, just the sum from n equals 1. Oops. N equals 1, 2, whatever this is, m of n. That's going to be equal to 1 plus m times m over 2. That's the formula. Okay. So if I just take this right here, let me just take it off. So Desmos can calculate. That's 15. This is 15. And so if you're going from 1 to 5 of n, that'll also be 15. So those are all different ways of saying 15. Now, why did I hem and haw and say that I screwed this up? These are not 1, 2, 3, 4, 5, 6, 7. They're still packets, but they're packets from this number. So this is what we do. So if we want those numbers, here's how we deal with this situation. We break it up into summation. So we're going to do, it's going to make this the sum from 1 to 4 of 2i or 2n minus the sum of 1 from 1 to 4. Okay. If I just check these, by the way, let me just see, that's 16. This is also 16. All right, now what happens when we add a number and there's no n in there? Remember I said you copy it, and then you replace the n's with 1. Well, there's no n, so you just do that. Then you copy it again, and then you copy it again, and copy it again. So this summation right here, this last summation, if I just ask for that, it's just going to be 4. 1 plus 1 plus 1 plus 1 is 4. Oop. And so that's what happens when you have a number. It's basically the formula for that is just that number times that number, 4. So it's just 4 times 1. The formula there is just 4. It's just the last times the number, which in this case is 4 times 1. Okay. Now let's talk about this one here. All right, so this one here, I know what this is. It's 2 plus 4 plus 6 plus 8. Okay, I plugged 1 into the 2, I plugged 2 in, I plugged 3 in, and I stopped at 4. Do you see that I can factor a 2 out of all of those? They all had a 2 in it, so I could factor them out. So I could basically write this as 2 times 1 plus 2 plus 3 plus 4. Would that be the same thing? I factored a 2 out. Okay? So basically, I could take this 2 and factor it out of the summation sign. That, because that's what this means, the sum of from 1 to 4 of n. And I can now use that formula. I can say 2 times the first plus the last times the last over 2. And I get that I should get the same every time. I should be getting the same number here. Why didn't I get the same? Oh, I need the same number here because it has to be a thing. 2020. See how these are all equal? Everything I'm doing is equal. 20, 20, 20, 20. And this one right here is 20. Okay. So we've learned some formulas. If we have the number 2, if we have, let's go back to the thing. So here's what I know to do with this problem. I can break it apart. I can take the 2 out and put it in front. Okay. And then I can, with that formula, I can do 2 times 1 plus 4 times 4 over 2. That's the formula for solving it without just the sum of n. That's that. And then minus, that's just the last, the number 4 times 1. And I get the same answer, 16. So you see, these are all the same. 16, 16. So now the thing is, what if I want the first 215 odd numbers? So what if this 4, let me go back here. What if the 4 is 215? Well, 215, that's a big number. But I can change these to 215 also. I can change this to 215, change this to 215. Okay. I can take the 2 out, just like it did before, make this 215. And this is still 215. Now, I can use this, for this one, I can use the formula. I can keep the 2, and I can do the first plus the last, which is 215. Right, that's the first plus the last, and then I want to multiply it by 215 over 2. Okay, minus. And then I have 1 215 times. Okay. So now I'm able to take something that's a summation and break it up, and now there's no summation in it at all. Just uses the first and last numbers of the summation. So if in your homework you're just asked to do a summation, just do a summation. Later on, we're going to use these formulas. So let's talk about the summations we have. So for this guy right here, there's a formula for this, just like there was a formula first plus the last. If you look at the answers, the formula for n squared looks like this. Let me just copy and paste it. This is the formula for n squared. Whatever number's up here, whatever number you put last, if it's 215, it's going to be 215 here, 215 here, 215 here. Okay, so let me just confirm that with you. They're the same answer. Okay, this is the formula for adding up a bunch of n squareds. So it's basically 1 plus 4 plus 9 plus 16 plus all the way to the last one, which is 215 squared. Okay. Over to. Okay, sum of a function evaluated at these numbers. So you have, what you want to do is so you're going to have a summation. Let me get back to it. So you're adding up, let me get down to here. You're going from 0 to 5, you're adding up 5 terms. It's going to be this function, and each time you're going to take this function, copy it, paste it. So you're going to plug a 1 in there first. So the first thing you're evaluating is the function evaluated at what is 0.125 plus 0.125? Isn't that 0.25? Okay, and then you're going to add to it the same thing, but you're going to put a 2 in for n. Okay, then you're going to add to it the same thing, but you're going to put a 3 in for n. And then the last one. I just make it smaller so I can make it bigger. And then the last one is the same thing. I'm going to put 4 in there. Okay, so what am I doing? It gave me a number too, 8.8. Is that the right number? Oh, it wants 5. It's going from 0 to 5. Okay, so hold on. I have to do one before. I put a 0 in here. And then I have another one at the end. See how I done that? I added the 0, the one. Honestly, these guys right here, I don't care about them. I care about the first one. So what I'll do is I'll check the first one. What's the first one? F of 0.25. And then I'm gonna do, I know the next one is 0.125 away. So all of these will be fine. I just want to add the last one, F of what is 0.125 plus 5 times 0.125 is 5.575. What's 0.125 plus 0.575? That equals what? 0.6.7. So I'm adding up 0.25 all the way to 0.7. F of 0.25 all the way to F of 0.7. Okay? And when I do that, I'll get 13.421. Okay? That's what happens when I plug in 0.125. It's the first thing I plug in all the way to 0.7. So that's not right. What's wrong here? I wanted the function evaluated at 0.125. Oh yeah, that's right. It's the first one. And then what's the last one going to be? 0.75? Is the last one 0.75? 5 times 0.125 or 6 times 0.125. Oh, yeah, that's 0.75. Oh, I'm sorry. This is just, that's why. That's a 0, so it's 0.125. And this one's 0.75. All right. So the first and the last one match up. And the answer that I get is 13.421875. Okay? And that's the answer, basically. All right. But what they do to find it, to find this summation, is they do F of the starting value, which in this case will be 0.125, plus the incremental difference times n minus 1. And you can go from 1 to whatever the number of terms there are. Or you can start from 0. You can go from the first value, add the incremental difference times n, and then go to the last value. Make sure that the last time when you plug 5 in, you get what you're looking for, which is 0.75. Okay, so this guy right here, I'm going to say the sum of the function g. What's the first term that I'm evaluating? Anybody? 1.16. 1.16. That's the first term. I don't know what I was typing, but what's some? 1.16. Then how much is it? How much does it take to get to the next one? How much? 0.2. Okay, so that's what we're going to do. We're going to add those one, and we're going to start with. So if I plug a 1 in there, that'll be too many. I want to start with 1.6. So I'm going to start with 0. Okay? And now the question is, how many terms do I add up? Well, let me just show you a quick and dirty way to do this. The table. If I start with 0.116, and the next one is 1.36. Tables do something interesting, Desmos. Watch this. They change by exactly the amount that it changes by. You have to end at 4 point, oops, how many? 4.36. Okay, so how many of these did I add up? One. So I added 1 to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it looks like 16 is the, I'm gonna add 16 of them. But let's just check the last one. Let's check the last term. What is 1.1? So if I copy this down, and instead of that, I put in a 16, what do I get? 4.36. Yes, that's correct. We want to end there, and we do. So that's the answer, 741.336. Okay? All right, for these, you just have to type, this is literally just type it in. I don't care. You can use some rules, they'll discuss them in there. Find the area under the curve. Now I'm going to tell you how to find the area under a curve. Okay? You want the area under the curve, this is all you have to do. If you want the exact area under the curve, type in the letters I, N, T, that gives you an integral. Start with the lower limit of the interval. The lower limit is 0. The upper limit is 1. Copy the function down. Actually, the function is already just, you could just write h of x, dx. And the answer is 4/3. Boom. Okay. You could also, if you didn't want to do it this way, you could literally type this guy in, copy. H, paste it in there, get rid of the H. That would give you the same answer too. Okay, so you either write the function or you write the, but it means the area under the curve. What does it look like? It means when 0 is less than, it's less than 8x. Look, there it is. Ooh, that's pretty. How'd I get that? That's actually, is it between 0 and 1? Yes, it is. That's the area we're talking about. So you see the function here? See the function? Everyone look, ooh, pretty function. And by putting this absolute value thing in, and absolute value less than, it just made sure that it only graphed x, y is greater than 0 and less than that function. Okay, not bad. Okay. Any questions before I move on to the next one? These are good questions, but I'm basically doing your homework for you. So it's a lot I can handle right now. All right, down to number 7. So number 7 says, we're going to take this graph. See, let's graph this graph. I need to see more of it. Okay, does everyone see this graph? There's the graph. Well, I want the area. It's a list of values. I'm going to slice it up into sub-intervals between 4.5 and 5. Okay, so let me just add a table here while I'm here. Add a table. And I'm going to, if I do 4 to 5, and I'm dividing it into 4 rectangles, so there's 4 into 4.25. Like that. And then this could be M of X8. Okay, so if I ask it to plot these points, where are they? I can see them. Oh, because you know what? Here, they're up there. There they are, you see them? Let me just kind of just adjust the wrench a little bit. I only want the X to go between 0 and actually I don't want 0, I want 4 to 5, so I'll just do 3 to 6. Okay, so those are the points that I want. Does everyone see that? Those are the points that I want. It's between one. So I actually want between x equals 4 and x equals 5. Okay, and the region, if I shade it, it would be 0 less than y less than m of x. But I only want between 4 and 5. So to chop it off, I'm just going to say brackets 4 x 5. There, and that's it, little shaded region that I want. If I want the exact answer, I could just literally do integral of, what is it, m of x. If I want that answer, I know that it's between 4 and 5. And it's m of x. So that's the exact answer. Cx. It's 29.33333. Now I want to approximate it with rectangles. But I don't, what they say in this problem is approximate it with the midpoint of each subinterval. So do you see the subintervals? Let me just break it up into subintervals by saying x equals x8. See those subintervals? Right? I don't want to use, so I'm going to create rectangles in each of those subintervals. And I'm going to use, I could use this value 4, and I could multiply it by a quarter, and that would give me one rectangle. I could use this value, I could use this, I could use these 3 values, and that would give me the left-hand side. If I add those 3 values up, I'll get those values, and I'll multiply them by the width, and I'll have height times width, height times width, height times width. I'm adding up 4 rectangles, and that will give me approximate area. Or I could use these. I could start with this one, and then all the way I could go five. That's using the right-hand side. Let me do it this way. This one, this one, this one, and the one there. I can't click on it. So that would be the right-hand side. Okay. Let me show you what they look like, because I actually have, that's a little more complicated for me to just throw up. Okay, this is it. That's that. Okay, I don't want those yet. Rectangles, the left side rectangles. Now they'll look something like that. Okay. If I do them, if I take away this, let me do this, but I'm just going to get rid of this -1/8 for a second. Oh, that took away everything. Okay, anyway, I want rectangles like that, but actually I want the midpoints. So I don't want the left or the right side. I want that point right there. And the way I get that point is it's 4.125. I'm going to evaluate the function at 4.125. That's the first one. The next one I'm going to evaluate it at is 0.25 later. So how did I get the first one? I took the 4. I know this is 4. I know this is 4.25. What's exactly halfway? Add them up and divide by 2, and you get 4.125. And then for the next one, just add, if the distance between these is a quarter, then the distance between these midpoints is a quarter, a quarter, a quarter, a quarter. So that's how all of these things get. So that's how I get them. I put the first one in, I added a quarter, and then I just had decimals connect. I just enter for the next two, and it gives me all those values: 26, 28, 30. Those are the heights. Okay, if I want the area, I'm going to say add up all those heights, which would be from 0 to 3 of 0.125 evaluated in the function. That's what this says. So once you're done with that, if you do that, you'll get this answer. You get 117. But that's can't be right because the base is 1 and the height is only about 30. So that's the answer is 30, not 117. But what you're doing is you have to take all those heights and multiply them, by the width. And the width here is times 0.25. And that's how you get a number like 30. Okay, so in this case, they're not saying just add up a bunch of numbers. They're saying, I want you to approximate the area by adding up all the heights and multiplying them by the width. And that's how you get those rectangles there in red. Okay. Note that you can start at the number 1 and go to 4, or you can start at 0 and go to 3. For calculations, I like 0. For understanding, I like 0. If you're going to use that formula stuff, you have to start at 1. Those formulas I showed you always start at 1. They don't start at 0, but you can start at 0 if you want. Okay. Anything else pretty in here? No. Okay. Let me turn that off and go on to the next one, because once we understand this, the reason why I'm giving you this one is because it has 4 very simple rectangles. They're midpoints, so they're pain in the butt, but there's 4, and that's 4 is fine. The next one, number 8, no, that was number 8. Number 9, it's going to ask you for 44 rectangles, not 44, 24 rectangles. Okay. Lights went on. No, they're blinding. Okay, I don't want any more of this graph, so can I turn this off? What is it? Why is it still graphing? Here it is. This point's off. All right, turn that off. All right, so now I'm going to do number 9. Approximate the area under the curve using rectangles with the left endpoint. I want 24 of them. So I'm specifically looking for between 0 and 1. So I'm going to say the x values go between 0 and 1. Okay, so that's from that 0 to that 1. Okay, and I want them cut into 24ths. So when I do a table, let me add a table here, add a table. I'm going to start with the 0. And then I'm going to add a 24th. No, so it'll be 1 over 24. And then I'm going to do 2 over 20. Then I'm going to, oh, that's a 0. 0, 1 over 24. If I hit enter, oh, no. It should be 2 over 24. And so on. And then the function is just going to be this right here. So copy. Paste, make that 9. Okay. So I'm going to add up 24 of these. They're all about 2. So in the end, I'm going to take about 24 of them. Actually, I know what they're going to do. Give me some. So I'll go from 0 to 23. I want 24 of them and 0 counts. So I'm going to take that function, k of x. I'm going to start with 0, because that's where I'm going, plus 1 over 24. One over 24. Times m. When I add that up, I get 55 something, something, something. Okay. So, but now I have to multiply it by the width, and the width should be 1 over 24. And again, if I want to test it, I can do the integral from what is this, 0 to 1 of k of x dx. Very close. Let's take a look at the pictures. Solutions has great pictures. Okay, so I found the incremental difference is b minus a over n, that's 1/24. So I want to evaluate it at 0 all the way up to 23 over 24. I don't want to do 24 over 24, just 23 over 24. Okay. And this is what I'm going to see. Oops, let me see, let me put the function on. So here's the function, it looks naked. There's the function. And there's 24 little rectangles there. Let me make them a little more showy. I want to go from 0. Looks like they don't get much bigger than 2 or 3, so I'll make it go to okay. See all those little rectangles? I want to add them up. All of them are about too high. They're too high. 2 times 24. 24 of them about too high. That would be 48. But each one, they're multiplied by 1/24. So we take 48 and divide it by 24, you get about 2. So the answer is 2.31. 2. I want you to, let me tell you the next one. So let me just show you some more here. So that last one, we don't add on. I put it on there, but we don't add it. We don't want the 24th one because that'll not be too many rectangles. Okay, here's the see the little pictures of them? Isn't that pretty? That is a nice picture.
We can make them even smaller so that we can be more accurate.
Exactly. That's where we're heading. 4 rectangles was good. 24 should be great. And it is. Look, it's
About
off.
100.
It's off by hardly anything. Wait, it's off by 200ths.
How about 200? How about 100?
Okay, so wait. So now you got the right idea though. Let me fill in a little there. So we want, that's the exact area. The green is the exact area. And the red ones would be here. That's the approximate area. And they're very close. Okay. But now what I'm going to do is I'm going to take this to more rectangles. I'm going to make 100 or 1,000 rectangles, but I can't draw all these lines. I'm not that good. Desmos needs stuff to make all those lines. This is pretty. It took me a while to make it. But let me just show you, if we take this formula, we can see some of the stuff about it. So if we want to do, I'm just going to repeat it. If we want 2,000 rectangles, we would just go 2,000 rectangles, right? But then that would be that 23. So this one, that number right here was 2,000 plus 1. Oh, actually, I'm going to put 2,000 here and I'll make this one less. Up there. There. And then I put another 2,000 here. And 1 over 2,000, thank you. Okay, do you see how my number just got better? It's closer to the actual number. This is the actual number. Do you see that? I'm very close now. I'm only off by 2.33308 versus 2.33333. I'm up by a really tiny amount. And if I make this 20,000 rectangles, Desmos can just do that. Now look, it looks like I have 4 digits and then left it. So see what happens if I put more rectangles. I just have to, I see how I'm getting closer and closer. 1, 2, 3, 4, 5, 1, 2, 4. I don't know if it's getting any better. Problem is, after a while, Desmos is going to have a hard time with tiny numbers. I just want you to know something. 1 over 200,000 is what? Big number or small number? Big or small? Small. When I start adding up functions that even if they're only worth 2, I mean, these are only too high. If I add 200,000 things that are too high, how much is that? Is that a big number or a small number? It's like 400,000.
Yeah.
So I have 400,000 on one side, and I have 200,000 on the other. Do you see what's happening? the one side, the more rectangles you use, the one side is going to infinity. The other side is going to 0, and I'm multiplying them together. And what is 0 times infinity, as it was on the test? What is 0 times infinity?
It's anything.
Yes, but now it's something specific. In this case, that something that it is the area under this curve. If you let this go to infinity, if you make it 9999999, you will approximate it with an infinite number of rectangles, and that will give you an infinite number, a really big number, but then you're doing 1 over infinity, that's going to 0. 0 times infinity gives you this answer, which is 2.33333. That's where we're heading. So we'll do that one day. But it will not add to your knowledge. It will only add to your headache. So it's not going to be today. I like this for approximating. Approximating the area under the curve, you don't, so now the next one, question 10, has 44 rectangles. Okay, let me turn off number 9. I think 44 rectangles I do have in Desmos, I think. Okay, so for this question, it says they want you to find the area under the curve from 0 to pi over 2. Okay, of the sine function. Why do I sell the function here? Okay, so I'm going to graph, just to open up this, I'm going to graph the cosine function like, oh. Okay, I want that. That's what I'm looking for. Between 0 and pi over 2, I want that shaded region, but I'm going to approximate it with 44 rectangles. How do I do that? I take pi over 2, which is the width. That's the ending amount and the first amount, and I divide it by 44. That tells me the incremental difference. Okay, I don't know what it is, and I don't care. It's a small number. Okay, then I'm going to say add up 0 to 43. That's 1 less than 44. I'm going to take that function. I'm going to evaluate it at 0. That's the first point. The incremental difference times the index times the incremental difference. And I get 10.177, whatever that is. To find the exact area is 10. Okay. This is the thing that shades in the region for you. If I'm going to see all those rectangles, here's the problem with seeing those rectangles. I can't see the rectangles. So if I create a table, let me just create a table and show you what I mean. I have started 0, right? And the next one has to be this incremental difference, which is this thing right here. Okay. And then I have to graph F10 of X11. So why is it entry cannot be a list of, oh, entry, sorry, my bad. So do you see those 2 points up there? Do you see them? Watch what happens now. So that's 1 and 2. Are you with me? Oh, come on. You can do this, Desmos. I don't know if it'll do it. Sometimes I have to do this. One of these. Okay. Let me see if it'll do it. Come on, Desmos. They want to see it. Not going to do it. Hold on, I'm just going to cheat. I'm not going to cheat. I'm just going to add another table because I think when you screw up a table, it doesn't give you a whole lot of leeway. Okay. Why is it giving me values when I don't have any values? Give it. I'm just going to do this. Do 0 plus 0 of these. And then I'm gonna put here, I'm gonna put 0 plus 1 of those. Line. So maybe if I have a decimal. It totally does it. Desmos does these things all the time. Let me just do it as a decimal. Pi over 88. So this is 0. This is pi over 88. And this is pi over 44. No, as a decimal then. How about this one? Hold on. Copy. No, still won't do it. 2 times that. 3 times that. 4 times that. They're really not going to give me 44 of them. Sometimes Decimals will do it, but it's not doing it today. Well, maybe it'll do it this way. Hold on. One more try. One more try. I'm going to try it. All right. Here's what I'm going to do. I'm going to put in 0, 1, 2, 3, 4. I'm going to put in 44 of these. Desmos couldn't deal with that. So there's 44 of them. 43. And then I'm going to, instead of putting just the function in here, F10, I'm going to put the incremental difference here. No, that's not going to graph it why I want to do it. Not at all. Anyway, I can't get it to do it. I'll have to think about it. But that's the point, is it would be a bunch of rectangles, but I can't see them. Desmos can't deal with them. Maybe if I asked for 44 rectangles, I would just see 44. It would just look like this shaded thing anyway. All right. So let me just say what we learned today. We learned about sigma notation or summation notation. It adds up stuff. We learned about definite integrals, giving us exact answers. Only using Desmos. We have more to do. And then we learned how to approximate rectangles. When you do your group work stuff, let's do, today's Tuesday. Okay, so today's Tuesday. So what was due today? Lesson 0. I don't think there was anything due today on the 29th. Mod 8. So you have to post your proposal tonight. You can change it. I just put it up there. Honestly, you can change it until I start grading them. And I probably won't grade them for a while. So as far as I'm concerned, there's nothing due today. I may not be in on Thursday, and I may not be in next Tuesday. I don't know. Thursday, because I'm tired. And if I don't get any sleep between today and Thursday, I'm not coming in. But next Tuesday is election day. So if Mod 8 is due, election day is November 5th. And while New Jersey is not a swing state, if you know people in swing states, go spend the day, harass them to vote. My sister lives in Pennsylvania. I'm going to harass her. But anyway, I may not, I don't know if I'll be in on the 5th or not, but you'll keep an eye out for me. And then when we do that, the thing that will be due is the area and average value. Okay, the area and average value for your regression project is the easier of the two things. So the area and average value for discussions, where's my discussions? There, it must be under my 8. It's Mod 8 is proposal. It's going to be under Mod 9. Okay, so here's the discussion worksheet for example worksheet. So you have some data and some regression, and you want the area between 0 and 20. All you have to do to do this part of the discussion. All this I put all this stuff in for you. If you just click on this circle, look at that. If you click on this circle, you have to click on both circles just in case. I'll show you why you need both circles. Just in case you decide to do a negative number. See, the negative area comes out to be green and the positive area turns out to be blue. But so if there's negative, when it's here, there's no negative. That's why it doesn't matter whether you turn the green one on or not. But all this says is, show me the area that we want. And there's the area you want. Between 0 and 20, it's that. Okay, that's all you have to do. Pick your endpoints. It's already in your worksheets. So whenever you adjusted this to whatever you just did to, it's going to tell you the area. Was the area between 10 and 20? It's that 7,661. Okay, this is the exact area. Now, this area isn't very useful. The units of this area, what is the area? What are the units of something that's length by width? Like if it's meters by meters, then the area is like square meters, right? But the units here are hours and miles. So that answer is 7,661 mile hours. What the hell's a mile hour? Have you ever had a job done and a contractor will say something, it'll take 6 people days. That means 6 people working one day or 3 people working half a day, right? It's how many people days it takes to get something done. If you have more people, it takes, if you have 6 people days means 3 people work 2 days. Okay, if you have 12 people, it's a half a day. Okay, anyway, so this does have some use in the world, but you know what's more useful is the average value. If this is the average, if these were the distances I was from home, this formula right here is the average value. Okay, we'll talk about it. The average distance I was from home was 743. That's way more useful. You want to know what the average temperature is in a day? You plot the temperature. You plot the temperature on a regression on it. You find the area under the curve, whatever it is, and you find that curve, find the area under it divided by the length, and you find the area average temperature of the day. Okay, instead of, people don't sit there and add up the temperatures. They pick a handful of them and they fit it to a curve. And then they find the area that gives us the average value. Okay, it's way better than adding up a bunch of terms. It's so much easier. Okay. So that's due, technically it's due next Tuesday, but if we don't have time, I'll just push it off to Thursday. Okay. But if any of you producers want to take care of it before then, you can. But I can't go on anymore. Let me take attendance though, because some people showed up. Who showed up? I don't know. I'm just going to take a picture of this. What I'm going to do. I can't even do that, right? Hold on. Do you have any questions on this? Do you understand where we're going? And honestly, we're pretty close. Once we have this integration thing down, the area finding out where it comes from, we'll be able to do all types of fun things with it, make some great statements, but we only have 2 things to say. Basically that one right there, which was the exact area. And then the week after that is when we're starting approximating it by using summation notation, so sigma notation. So that's all we have left to do in our project. It's either find the exact area or approximate area. Nothing else. Okay. And then we'll talk about some other things, but we don't have a lot more to go in topics. So if I miss the next class or so, you can holler at me, but I have videos and stuff that you can watch. I'll let you know. But don't come to class without checking first. Here, class questions. I'm going to answer. I'm just taking attendance. Acacia. What are the 2 rates of change? You were here today, right? Kirby hasn't been here forever. Acacia, what other two rates have changed? Just want to hear your voice.
Average and instantaneous.
Sebastian. He was here. He left. Pamela, you're here. What's the
Yeah.
derivative? What's the derivative of sine?
Uh,
Just
Cosine.
Jonathan. I don't care what the channel says today. Pavani, are you here? No. Alicia, are you here? What does the mean value?
Yes, I am.
What does the mean value theorem say?
Derivatives exist on AB so that it equals average rate of change, I believe.
Something like that, sure. Eric, what's 0 times in? What's a 0 times infinity, Eric?
It's anything.
But what is it specifically today? What did we learn that 0 times infinity could be?
The infinities and the number of and zero, or even zero.
Okay. Hayden. When can we use L'Hopital's rule?
0, 0.
Good. Selena.
Yeah,
What's an inflection point?
is when the concavity changes.
Thank you. And Luke, what's a critical number?
It's an x value where the derivative is 0 or undefined.
Thank you. Sorry, I'm just using the same old 10-inch, but did I get everybody? Carlos. Carlos, are you in this class?
Yes.
Oh, well, let me ask you a question, because I don't remember asking you a question. No, I didn't. So let me change it. Change it to somebody who hasn't answered anything. Carlos, what does Newton's method do? You remember?
Find zeros.
Newton's method? Find zeros. Yep. Thank you. All right. I don't think I can do much more today, but so you're gonna do you have a quiz due next Tuesday, quiz 8? Quiz 8 is not showing up here, but it will. So do quiz 8, do the homework, and then you quiz 8 is on summations and stuff. Let me do quiz 8 for you. Hold on. And so I want to let you go, but now it's to 7:40. And you guys aren't saying anything. I took attendance, y'all could go. I'm just going to I'm going to breeze through quiz 8. Because that's the one that it's not gonna be due next week. I'm gonna push it off. Where's quiz 8 MC? There's 9 MC. Where's quiz 8 MC? What's it there? Did you see it? 7 derivatives, midterm 6, 7, 8. 1, 2, I need to find 8 MC. There's 9 MC. There's 10 MC. Where's 8 MC? Hold on, I'm gonna find it. I'm gonna find it this way. Right. I think that we're okay. 2024 spring. This way, up in body. Here's 8 MC. Oh, because I installed it already. That's why. But here it is. How do we use segmentation to approximate area? We add up heights and we multiply them by widths. Other things that were discussed was a definite integral is used to find the area, and a definite integral, but those are ways to find the exact area. Add up terms is what sigmas do. Definite and indefinite are the types of integrals. Area and antiderivative are the things that the definite and indefinite integral find. And when is the graph below? When the graph is below the x-axis, that's when the area is negative. Okay, but adding up heights and multiplying by widths, that answers this question. Say this. So this is the sum as n equals 1 to 100 of the quantity n squared sum n equals 1 of the quantity 2n minus 1, not that one. The quantity 1 minus 2n, no. Oh, how about this one? The sum from n equals 1 of the n squared is that number right there. That looks good. Okay. 338,350 is probably all of that multiplied out. Okay. What happened here? They're adding up. So in this case, they're just adding up a bunch of values. This is not an area. This is adding up a bunch of values. This right here, they're using properties of summations and breaking them apart. This one here, this is not just adding up things. This is adding up things and then multiplying by the widths. That's an infinity times 0. That's an area, approximate area using 3 rectangles. Okay. This one's an approximate area using 44 rectangles. This one's approximate area using 24 rectangles. This one's finding an so this is finding an exact area. Okay. So those are some of your options here. Right. So what was 4 and 5? I didn't see what 4 and 5 were. 4 and 5 were. I used the formula. That's just one of the summation formulas. Remember the one with 46 in it? So that's just to use summation formula to compute the sum. Okay. Was there 2 of them? That's not cool. Okay. Sum the values. That's all of these. So I just have to go in here. Hold on. Let me copy and paste this. Copy. Paste. Here. Oops. Okay, so I want that function. So I'm going to do it this way. It's going to be easier. I want to go from 0.1 to 40. So I can take 4.0 minus 1.0 and divide that by the difference between them, which is 0.1. No, that's it. 4.0 minus 1.10 divided by 0.1. Okay, how much is that? Okay, there's 2 dots there. Okay, that's 39. That's not 30. That when I go from 1 to 40, I know there's 40. When I did that, I subtracted. From 1 to 40 is 40. This is actually 40. Or you could go from 0 to 39. That's what I'm going to do. So 0 to 39. The function is x squared plus 2. So I'm not going to put the function in. I'm going to actually put in 0.1 times n. That quantity squared plus 2. But I have to be careful. When I do plus 2, I have to put the whole thing in parentheses like this. Okay. So my answer is 285.4. So I'm just adding up a bunch of values. There's no increment. If I went in an area, I would multiply it by the incremental difference here, which is 0.1. So 285.4 next one is. Okay, here's a COVID of us. Oh, COVID's of us. Find the total number, use the integral to find the total number of cases from weeks 2 to weeks 28. So weeks 2 to weeks 28. And that's the answer, 14,799, 14. Whatever. Copy. Back here, paste it in. It says to whole numbers, so that's going to be an 8 there. Now you might be asking me this question. That's the area under the curve. Isn't that people years? This is the number of cases. Well, the thing is, they don't count a case. If you're sick with COVID today, well, I don't know. Let's see if it's right. How'd we do? Okay. We got this one wrong. Use some, oh, because there's 2 of the same. There's 3 of the same, they all say the same thing. That should have been fixed. If you see anything like that, let me know. I don't know why I got this one wrong. That one was right. So let me just talk about this last one of the COVID cases. When you're doing an area under a curve and you have a number of cases, you have to ask yourself a very important question. Do you count the cases more than once? Okay, so when this curve is estimating the number of cases, it looks like the number of cases dropped. So they're not obviously not counting the total number of cases ever, because if they're adding total number of cases, it would just keep building. But since it dropped, it means that it must be the number of cases they have in the hospital at that time. The question is, do you count a person from 1 week to the next? So if it's new cases, then no. If you're a new case this week, you're not a new case next week. But if you're a case this week, you might still be a case next week. That gives different answers because the total number of cases can't be determined then. Do you know what I'm saying? If you count something more than once from year to year to year, week to week to week, you don't know how long that person was still a case. If somebody told you, well, a person definitely with COVID has 2 weeks, then you might be able to take the number divided by 2. You might say, okay, well, if they're a case this week, they will definitely be a case next week, but not the week after that. So you could definitely do something like that. But if you don't know some other piece of information, you can't do it. But this must be the number of new cases. So that's why it works. So since a new case happens each week, since a person's new case doesn't count from week to week to week, then it's okay. But if they're counting the total number of cases, this is a problem. And we'll talk about that. Okay, the time's definitely up. So I'll talk to you next time. Maybe. Do we know why this one was wrong? Oh, you know why this was wrong? Did I square the answer? I don't believe I did. Hold on, when I did that summation, I did square it. 0.1 n squared plus 0.9 plus 2.
You said no class.
May not be class, check with me on Thursday. Let me just see. I'll go from 1 to 40. If I plug 1 in there, that's right. That's why I went from 0 to 30, and it has to be from 1 to 40. Then I get the right answer to be at 1.4. Okay, you're at 1.4. Sorry, I'm tired. I'm letting you go. If you have any questions, speak up. Otherwise, I'm ending the